And just one more question. Let me give it another minute. So let me start. Just one more question. And those of you who've tuned in, if you could just let me know, you can hear me in the chat, okay? All right, great. Thanks so much. Okay, great. Well, I'm going to get started then. I want to thank you all for attending today's webinar on electromagnetic applications with Feko. My name's Drew Buchanan. I am a senior applications engineer here at TrueInsight. Just a little bit about who I am. I am based out of Philadelphia, Pennsylvania, and I've been in the analysis space now for almost 2 decades. Spent about the first decade of my career in industry, ranging from biomechanical research to power generation for renewable and nuclear energy to consulting. And then the past decade, I've been in the reseller space. So I'm excited to kick things off. I'm actually going to hand it over to my colleague, Kyle.
Yeah, thanks, Drew. Can you hear me okay?
Yeah, I can.
Okay, fantastic. Well, thank you, everybody, for joining. And for those of you who've joined us and maybe aren't familiar with Altair, I think you'll find that you've heard or used some of the products before in the past if the name Altair doesn't ring a bell. But some of the brands that live under the Altair umbrella or a suite of FEA tools, HyperMesh, OptiStruct, and Radiosis solvers that are very, very well known. Feko, which is what we're going to be discussing here today. Reason being, we're seeing so much demand and increase and so many questions coming from new customers and customers who maybe haven't been in the electromagnetic space, but with everything going the way of antenna design and electric motors and batteries and things like that, we're getting more and more questions. So we wanted to have this webinar to really address those questions and again, make sure that people understand who Altair is and really what their vision is. And the vision is, to transform the enterprise. And really, by enterprise, that doesn't just mean large corporate conglomerates, but small and medium-sized businesses as well. Their decision-making by really converging simulation, high-performance computing, and artificial intelligence. So now we're getting into the next generation of iterative design and FEA and what that looks like and how these tools work together. And the other unique thing that Altair and TrueInsight bring to the table is gone are the days, or they're going away, where you had to pay very, very large sums of money for each individual application that you wanted to do, depending on the problem and the physics that were behind that problem, where now, you have access to this broad suite of tools with multi different solvers, as well as the pre and post on the back end. And then to go along with that, inside the solutions portfolio, you have a data and analytics AI where you can bring in all the different results that you're getting from your various studies, the data behind your CAD, and even how your CAD trickles down to your bill of materials and accounting, and utilize that data in a more productive manner. Multi-physics simulation, even tools around design, modeling, and visualization, Internet of Things, and then HPC. So we have options for those joining the call if you're worried about, okay, this is something we want to get into, but maybe we don't have super high horsepower machines or access to clusters. That's something that we can provide as well. And then there's the Altair Partner Alliance that many may not know of. And essentially what that is if you're an Altair customer in one of the suites, you have access to 100+ other different tools that aren't Altair owned that you're able to use as part of that suite without having to pay additional fees or having to buy additional components. So next one, Drew. And just very, very quickly, so you're aware of the kind of foothold that Altair has, in the market. these are large names, but again, TrueInsight and really what TrueInsight's intent is specifically in North America is getting out and getting the small and mid-sized business access to these tools that maybe in the past people have thought, because of other tools in the market, hey, we can't afford high-end simulation. It's far too expensive of a tool, or we don't have, the right engineers on staff to use that. Those days are gone. We now have, it's really democratized to all industries, all customers, shapes and sizes, regardless of what your application is. So just wanted to touch base on that again, so people who aren't familiar know who Altair is, know who TrueInsight is. TrueInsight is the channel partner for North America. We came because as Altair started to really pick up steam in the market over the course of the past 3 years and displace some of the larger high-end FEA brands out there, there absolutely was a need for, in the small and mid market, for a direct reseller to be able to support the customer base, have a direct line in for feedback, and provide training options as well. So we cover that entire gamut, and really look forward to presenting what Drew's presented with you today. So Drew, from there, I'll let you take over and begin with the show.
Yeah, thanks, Kyle. Really appreciate that. So thanks again for that. So yeah, the agenda for today's webinar. First, we'll kind of go over some of the electromagnetic simulation options within the Altair suite. Then we'll actually be covering kind of the bulk. We'll be looking at Feko and Winprop. And again, this is a short webinar. It's impossible to cover every sort of application within Feko and Winprop. So I encourage you guys, if you do have questions, let us know in the chat, or happy to sort of set up a call following that. And then at the end, I'll sort of touch on Altair One, what it is and how it can kind of benefit you guys as you sort of utilize the Altair suite of tools. So when you're looking at Altair and sort of the high frequency simulation solutions, we have a number of simulation solutions. Now, it would be remiss of me not, this webinar is focusing in on high frequency applications, but if you are dealing with both high frequency and low frequency applications, Altair does have solutions for that. One of the nice things about purchasing a license of Feko is it gives you access to the low frequency application, which would be flux. But dealing within the actual high frequency applications, we look at Feko. Feko can really be utilized to solve a variety of problems. We have a number of customers in the automotive and aerospace space. Looking at all the autonomous vehicles now, it's very vital to be looking at antenna design and antenna placement for all the vehicles we're seeing out on the road. Nufisat actually allows, if you're familiar with radomes, it allows you to sort of analyze those specific applications. Winprop is something we'll actually be looking in a little bit more depth in this webinar. Definitely with the prevalence of 5G, it's definitely a very useful tool. One of the great things about Winprop is you can feed in some of your antenna designs from Feko into a map like you sort of see right there if in a city environment, and actually sort of see your range and transmission for Winprop. RAP is a spectrum sort of management tool. So, making sure you don't have any interference across your sites is very vital. And then PolX, kind of revert back to, any antenna application, you probably have some type of PCB sort of utilized in that design, looking at signal integrity and power integrity. One of the great things about Altair as a sort of a simulation suite is all these tools can work together. And you'll sort of see as we sort of step our way within the actual Feko demonstration, you can kind of see some of the power of leveraging some of these other tools and kind of coupling scenarios together. So what exactly is Feko? Feko is an electromagnetic simulation tool, and it allows you to solve a variety of problems. Some of the key kind of simulations that I see a lot of our customers utilizing it is, like I sort of mentioned, for antenna design, or in placement, but there's a lot of other applications you can utilize the tool. You can sort of look at cabling analyses, scattering, bioelectromagnetics, and EMC capabilities. And one of the great things about Feko is it has multiple solvers. So if you're familiar with Maxwell's equations or kind of traditional sort of electromagnetic equations, it can kind of take advantage of different solvers to one, actually solve more complex problems, either if you have a lot of frequencies or high frequency applications, or if you have very geometrically complex tools like a vehicle or a boat, you can sort of solve some of these more complicated problems. The great thing about it versus if you've ever used, any other EM tools on the market, it's very easy to use and kind of get up and running with it very quickly while still being able to solve a variety of problems. So this is kind of what I was sort of mentioning earlier. Feko kind of makes it very unique is it has the ability to utilize multiple different types of solvers. So if you've ever heard of MOM, that's method of moments, kind of a very standard EM sort of physics solver, but there's a lot of additional solvers within the Feko suite. There's finite difference time domain, UTD, some of these solvers that allow you to, one, if you have very complex materials, like you sort of see the application below for biomaterials, you can sort of solve it within Feko, ranging up to aerospace or marine applications where you have very high frequencies. The great thing about this too is you can couple these solvers or utilize hybridization to solve these solvers. So for instance, using a method of moments of ray tracing to solve, an automotive or marine application. Point being is you have a lot of solvers at your disposal to solve some, either electrically complex or geometrically complex applications. Okay, great. So let's hop into Feko. Okay. So when we look at Feko, I have the tool open right now. One of the great things about this is you sort of see Feko. We're going to get into Winprop in the second part of this webinar, but you also sort of see the tools I mentioned in the previous slides, which were Newfasant and Wrap. It's very nice to have everything in the environment. So when we look at Feko, CAD Feko is where you sort of set up your problem, where either you create your geometry or import your geometry and set your boundary conditions for the system. Post Feko is where you post-process or look at your results. And then edit and QFeko are more for batch running or sort of editing scenarios. So we're going to launch CAD Feko, and we're going to go through our actual setup of this model. So I'm going to create a new model, and you kind of see the actual environment right here. It's very nice. There's a nice sort of ribbon sort of format in terms of if you ever use Office, it's very similar in terms of how things are set up. A lot of the workflows I deal with customers is they're actually importing geometries in. So you can actually import a geometry. And if I actually show the geometry, one of the great things about Altair is it's very solver neutral. It came out of the sort of automotive space when it sort of formed in the 80s. And one of the sort of conditions of that is it has to be able to sort of bring in multiple file formats, and that's across the board. So you can bring in an actual geometry file, or if you want, you can bring in a mesh. So if I wanted to bring a mesh, I know I've had customers in the past that are utilizing just code in terms of how they create a mesh. They don't have access to CAD tools. You can also bring in an STL mesh directly into Feko and set up your problems accordingly. In our case, we're actually going to set up, you can actually construct geometry as well within Feko. So we're going to do that in our case. So the application we're going to look at is we're going to actually look at sort of antenna design. We're going to look at a horn antenna from a design perspective. So, if we look at our construct tab here, we can specify, we can actually create solids, surfaces, and curves. The first thing I'm going to do is I'm actually going to specify my units. So I'm going to go to centimeters. That's just the units I have for this antenna design. The other thing to keep in mind, if you're familiar with scripting or writing macros, you can take advantage of those capabilities as well within Feko. All right, so let's actually create this horn antenna. So I think once you guys see it, those of you who are familiar with horn antennas, you'll know what I'm talking about. But once I get this created, you'll see what it looks like. So I'll go to my solid. I'm going to create a solid sort of rectangular prism on the bottom, and then create the flared sort of antenna portion on the top. So key in my sizes here. And I can also give labels so I sort of understand what's happening. If ever I need to open this or a colleague needs to open it up, you'll sort of see that geometry is created. And I zoom out, you sort of see the bottom surface of my system. Now I need to sort of create the top of my flare, and I can actually specify right on that top surface and then just key in the appropriate sizes here. So, you saw how I did that. It was all just done through just a shift and a mouse click. So it's nice. I don't have to retype in those commands. It's very nice in terms of the GUI environment. And I'll key in a couple parameters here. I want to sort of adjust the height, the width, and then the overall depth. Hit create. So once I create that, this probably is looking more familiar to you guys who have ever done any type of antenna design. And this is all going to be one part. So what I'm actually going to do is I'm going to create a Boolean, in CAD terms, if you're familiar with that. In Feko terms, it's just creating a union. So that's going to be sort of one entity. And when you see when it happens, kind of the default parameters specifying a value as an electric conductor. You can also change the media type, for non-antenna applications. Maybe you're looking at EMC applications where you need to change to a metallic medium or dielectric medium. You can specify those criteria there. But I'm going to kind of keep the default properties. But one of the things you'll notice here is we need to have this open, kind of representing what we expect with a actual antenna. So we actually need to sort of open this up. And if we go under our details right here, so right below our model tree, I can click on these faces and they'll dynamically highlight, you sort of see, until I get to the top surface, which I don't need. And I right click and hit delete. And that opens up our horn. If we zoom in, we want to actually have this go from the bottom, kind of like a traditional antenna. So we need to delete this face too. And that is face 13. So I'll delete that. And now we have sort of created our geometry. If we wanted to, we could have skipped this step. I could have directly imported this geometry in, and that might be a workflow for some of you, if you have CAD tools or you're already creating your geometry, you don't have to construct directly within Feko. All right, so now we can actually go through the boundary condition setup. So if I work my way from left to right, I can actually work my way, to the boundary conditions. The transform ribbon icon here is for if you're importing any geometry into the system, and you want to do some geometry cleanup in Feko, you can do that. We created our geometry, so I don't need to look at the transform tab. Cables, I can actually specify a cable path or cable harness. That's for another type of study. So like I sort of said, we're just sort of hitting the tip of the iceberg with Feko, but we'll actually go to source load. So in our case, we want to sort of understand how effective our design is for both near field and far field applications for our antenna. So we're going to specify a waveguide. So we look at our waveguide source here. We can actually click our bottom surface, hit create. And then we just need to specify what modes we want to excite for it from that actual waveguide port. So if I click on waveguide source, you sort of see it automatically recognizes, hey, you've created this port. If I had multiple ports, you'd actually have a drop-down list right here in terms of the ports you want to utilize. So in our case, I just want to excite the fundamental mode, so that's going to be fine. So, at this point, we've now gone through the actual, we can actually specify the frequencies or what we actually want to solve for in our case, looking at this frequency or this antenna and sort of understanding its design. We could very easily just right click and hit, frequency. But one thing I want to point out, which again points to the ease and iteration, which a lot of our customers utilize Feko for, is actually being able to create variables. So I'm going to name this variable as freak. And I'll explain why in a moment, why I'm actually creating this, but there is a reason for this, and you can use this across the board in Feko. So when I do that, you sort of see within my variable tree, you sort of see this item freak equals 1.645 e to the 9th, and then you sort of see the speed of light and some of these other kind of parameters like pi, which are set as variables. So what happens if I actually right click on frequency, I can, instead of typing in a number, I can actually type in this variable. And why this is useful is if you have multiple frequencies or you're doing multiple iterations, it'll save you a lot of time. Instead of having to type in a frequency every single time, I can just, specify freak and maybe divide this by 4 or multiply it by 4, I can actually utilize my variables with mathematical expressions, which is nice. So if I hit OK, you'll sort of see now that it actually populates with that specific frequency. And now I've actually have everything I need on the actual boundary condition setup. I have my waveguide source, I have my geometry, I have my properties defined for it. Now I need to specify what I'm actually solving for, what I'm requesting. So if I go to the request icon right here, this source load represents boundary conditions. You kind of see there's a lot of other applications we can talk about. But if I go to the request, this is what you're solving for. So you kind of see, you can look at SAR, you can look at a bunch of values, but in our case, when we're looking at antenna design, we'd be interested in our near fields and far fields. So if I go to near fields right here, I can specify, when I'm really trying to measure the effectiveness of my antenna design, I want to look at both near fields and far fields. So near fields being looking at, the gain or sort of magnetic sort of results at a specific location. And in our case, I can key in the values of where I want this near field to be requested at. So in our case, I can type in my values. That just represents the geometrical coordinates. And as I type these in, you kind of see that green box appearing. That's representing where that near field's going to be. And as I zone in it, you're going to see it's going to be the top surface of the antenna or the horn antenna at the exit. And that's really what we'd be looking for from an antenna design perspective. So type in our values here, and you sort of see that that's where our near field is going to be requested, and solve that. Great. We hit create. We have our near field applied. We can also apply a far field, and we can just use a 3D pattern representing our system. So at this point, we've now set up our system in terms of boundary conditions and also our requests. I'm just going to hide these just to make it a little bit easier. A couple other kind of really cool things about Feko, obviously we can solve a variety of problems, but in terms of our solving, we can also, if we have a symmetrical model, we can take advantage of symmetry. So what symmetry is going to allow us to do is actually solve our system to sort of reduce our computational. And what magnetic and electric symmetry is and how to utilize symmetry, we do talk about that in training. I'm not going to spend too much time on it now, but the purpose of doing this is to sort of reduce our computation and get our results a lot quicker. Okay. I can also turn off these planes if I don't want to see them. So if I go to my display options, I can turn off the symmetry. So I'm just going to turn those off so I don't see them. The last step is now actually creating a mesh. So we've created the geometry, we've applied our frequency and our boundary conditions. The nice thing about Feko is you can specify, you can actually get pretty granular for your mesh, or you can utilize sort of the automated mesh. How mesh is created is a sort of a combination of your geometry and parameters and also your frequency. So if you have very high frequencies, you're going to have more elements in terms of a finer mesh. Lower frequencies, it's not going to be as fine of a mesh. So we're going to utilize a standard mesh. And again, meshing sizes and mesh parameters are things we talk about a little bit more in depth, but meshing in this, you sort of saw how easy it was to kind of create that mesh. All right, great. So now at this point, the system's been set up and we're now ready to solve. The last thing we can do right before solving, and I kind of pointed this out in one of my earlier slides, is the ability to actually specify what type of solver I'm utilizing. The default is we're going to use a method of moment solver. It's a lower frequency application, but I could actually specify multi-level fast multipole method, high frequency solvers. That's one of the really cool things about this is I can specify these solvers accordingly and solve problems that could be very, very complex. All right, so I'm going to hit OK, and I'm actually going to solve the system. So it's going to ask me to save it. I'm going to save it here, and it's going to go through this run. The other nice thing about Altair is it has the ability to scale solutions, meaning if I wanted to actually take advantage of multi-core applications or having additional memory, you can scale these problems or utilize GPU to run your systems as, even quicker than you could in other EM tools in the market. So if I hit OK, the system's now solved, and we can actually click on Post Feko and look at our results. So again, I'm going to turn off the symmetry because I don't necessarily want to see those as we're viewing our results. And you sort of see the really nice thing about this, even though Post Feko is technically, slightly, opens up a different window, has the same ribbon format. So that's one of the nice things about in terms of looking at Feko. It keeps things very easy from the GUI and the interface. So in our case, let's take a look at the far field. So all I have to do is drag far field from my requests, and I can directly see what's happening with the far field. I can sort of change, so I can sort of understand directly what the far field is going to look like. I can change, I'm looking at gain, I could look at electric field, and I have a variety of units of what I can look at. Additionally, if I wanted to actually, look at my results, if I want to look at near field, I could turn on my near field values. So if I go to near field, I can directly see how effective my antenna design is going to be. So I'm looking at electric field. Maybe I want to look at my magnetic field and see if this is a good design. And what I'm sort of looking for. We can also look at traditional 2D plots, which a lot of you are very familiar with in terms of polar plots. Looking at far field on my polar plot, you have that ability as well in terms of post-processing. Everything on the post-processing side of things can also be saved or exported out. So even if you have users not within Feko and you're trying to sort of show your designs, it's very easy to sort of send these results out to PDFs, Word documents, etc., as well as sort of animating results if you want. Great. So I'm going to jump back into my PowerPoint right here. And again, it's kind of the tip of the iceberg of Feko, kind of gives you an understanding. But what we can kind of take from that Feko run is we can feed that data into Winprop and look at sort of radio propagation. So like I said, a really good application of this is deployment for 5G and sort of seeing how effective your antenna patterns are across a city environment. So you can utilize Winprop. Like I said, it's a simulation software that's focused on wireless propagation, modeling, and radio network planning. There's not a lot of tools out there that have this capability of both running electromagnetic simulation, but also looking at wireless propagation. So looking at radio coverage for topographical applications, but also urban environments. The other cool thing about this is you can actually have a hybrid scenario. So when you're looking at these buildings right here, you can have them actually look at the wireless propagation through the buildings on the interior as well as on the outside. So we're actually going to jump into Winprop now, so you guys can all take a look at what that looks like. And let me come back to my main environment right here. So right within your main sort of banner of Feko is I can actually specify Winprop. And very similar to how Feko is, where the preprocessor's on the left, the same thing can be said right here with ProMan. So we go into ProMan and we can specify we want to start a new project. And this will tell you what type of study you're actually going to be running. So we're going to look at propagation analysis, and we're going to be looking at urban scenarios, and we're going to specify our building data. So we're looking at Frankfurt. You can actually bring in your own 3D building data, or you can create it directly within Wallman, which is the CAD tool within Winprop. So you can either bring in your geometry or create it directly within Feko Winprop. I'm going to hit OK right here. I'm going to maximize my screen. So this is pretty cool. I've actually been to Frankfurt. So it's definitely really cool when you can kind of see the environment of different cities and really being able to simulate applications. So why are we going to be using Winprop right here? Well, we want to look at our wave propagation of an antenna on this specific building right here. So that's what we're going to do. We're going to go through this setup and we're actually going to specify that. And it's pretty easy to do. We click on this little icon right here, which represents antennas. And we can specify what type of antenna it's going to be. We're going to specify it's a 3 antenna sector site, meaning that there's going to be 3 antennas at that specific site. And once you do that, I can click, just by mouse click, moving around the application. Most of our customers who are using Winprop, they're probably going to have a lot of different antennas, different sites. So in our case, in this webinar, I'm just going to do one site. But you can kind of understand the actual process of how you key in your settings and for multiple sites. So the first thing we can do is we can specify the height of this antenna. Like I mentioned, with Winprop, you can do hybrids where you're on kind of the bottom environment, but we want to have this at the top of the building. So I'm going to specify 135.84 meters is going to be our antenna. And you'll note that since I specified a 3-sector site, meaning there's 3 antennas at this location where I did the mouse click, I can specify those specific antenna settings. In our case, I'm going to specify the frequency that I'm going to use for propagation, what my actual orientation is going to be for that antenna. And here's where you can read directly from Feko. So, you can actually utilize your antenna designs from Feko from the antenna pattern right here, which I have created and saved and hit OK. And I'm just going to key in the following values. They're all, it's going to be all the same propagation. And Feko's Winprop is smart enough to understand where I already mouse clicked, but if I did want to make changes, I could edit these accordingly. But I'm going to use where I picked on my mouse click. Great. I just have one more, and you note when these update, it'll always tell you your Feko pattern. So the other thing is, if you don't want to use Feko for your antenna pattern, you technically can all create it within Winprop. But that's the advantage of having Feko, is you can kind of create those antenna patterns directly and kind of go from there. Here's my last one. Remember, this is all my settings, and what I'm actually solving for in Winprop is I'm specifying these antenna and the antenna pattern, and I want to sort of see what happens across the city in terms of wave propagation, what's going to happen. And there we go. You sort of see I have my antenna. If I zone out, you always know once you've defined it, it's telling me it's a 3 antenna site, and that's specified at that specific location. So now, if I wanted to, I could create multiple antennas. And like I said, a lot of our customers are doing that, but I'm just going to use one antenna in terms of, for sake of time, in terms of going through this. So now that we've specified this, we just need to go through our actual project settings. So if I go up to project and hit edit project parameter, this is our resolution. So depending on how large of a map you have, this is something that you could have a very fine resolution. It might take a little bit longer to solve Winprop, or you could have a very kind of coarse resolution. It wouldn't take as long to solve. So I'm going to go with kind of a default sort of resolution of about 2 meters. Once I key that setting in, I need to specify what I actually want to look at from a results perspective. In our case, I want to look at field strength, our path loss, and our loss analysis. So really being able to understand what's happening in terms of really our wave propagation and field strength of these antennas. If I go to sites, you'll sort of see all the sites I've created. You could actually manually create a site within here too, but I typically always am going to revert to the actual site boundary conditional within Winprop. But it's nice to have different areas of how you sort of access or sort of make these changes accordingly. Let's go to our building data. So you sort of see the building database. It's utilizing that Frankfurt database, which we see directly. You can also, in addition, add additional topography. So maybe you didn't model the topography in your building. That's another pretty cool aspect. If a lot of cities, globally have different sort of topographical features, you can add those accordingly, which was very, very nice. So I'm going to use the rest are just default settings in terms of how it's solving. You can sort of adjust these accordingly. And again, these are things we talk about much more in training, but in this case, the default sort of solvers and computation is going to work fine. I'm going to hit OK. And then at this point, I just need to solve my actual system. So if I go up to computation and hit compute all, and I'll just use the default sort of saving here. And that's not going to go through. So it's going to show you that it has 3 transmitters. And remember, we're solving for 3 pieces of data in terms of our our propagation, our path loss, and then it'll actually finish it. So you sort of saw having kind of a medium-sized resolution, it solved relatively quickly. So if I go to my results now, this is a really kind of cool thing. I can look at my field strength, my power, but the other thing is I actually can look at my 3D results. So it'll just sort of generate right here, and I can zoom in and take a look, and you kind of see the building with the antenna right there located. So this is very, very useful in terms of understanding what's happening, seeing our field strength, where it's kind of close and where it starts to kind of weaken, where I look at my path loss, my power, and my loss, really just giving a really good understanding of what's happening within our systems. Great. So like I said, kind of just an overview of Feko and Winprop. Really, again, tip of the iceberg for the webinar. You can really do a lot. Just for your reference, this is actually Manhattan, which is pretty cool. But in terms of what you can do in Feko and Winprop, one is there's multiple solvers, and you can solve very complex problems or geometrically complex scenarios. So if you have large frequency applications, you can solve, or very complex geometry. In both Feko and Winprop, you saw me run through today. You sort of saw how easy the GUI is. You have the capability to script if you want, but the GUI is very easy to utilize, and you can set these scenarios up very quickly, which is what you guys would be utilizing the tools for. It allows you to iterate and solve these scenarios efficiently. There's a large number of features or material databases. So, one of the things within Feko is you actually have components you can add. So you have different material databases available to you. And lastly, you have the option to couple simulations of other modules. So you saw that Winprop works in conjunction with Feko. So you're coupling scenarios, but you can also couple, like I mentioned, Feko with HyperWorks or HyperMesh or other tools within the Altair suite. So segueing into that point, what exactly is Altair One? I just wanted to cover this, just give you guys an understanding of what Altair One is. Altair One is Altair's environment. It really allows users to access simulation and data analytics technology and scalable HPC very efficiently. One of the beauties of solving solutions within Altair is that actually, you can actually utilize multiple tools at once, and the licensing is very easy. So if I actually come and show you just a quick overview of this, just so you're aware of it. And I'm coming at this just from my own perspective of using some of the other tools on the market that are a little bit, they don't have this capability. And what I mean by that, when we'd be looking at Feko and Winprop, you'd be in what's known as the multi-physics mechanics engineer suite. You'd have access to these other tools. So when you purchase a license of Feko, it gives you access to utilize these other tools. So like I said, even though we didn't cover Flux, which is the low frequency application, it would give you the ability to do that. The other power of Altair One is it allows you to sort of have Altair be responsible for the actual sort of managing of the licenses. So, if all you have to do is, go onto the environment and specify, sort of see me right here within our company, our users, and then you can actually add as many users as you want. It's not a named user-based license. We have other license options available. So maybe you're a defense contractor, you can't utilize an internet connection. All the Altair One is utilizing is just the internet connection for the license. But it makes things very easy. You can add an example of me as I have my work computer, and then I have my sort of home computer. I can install Feko on both computers, and if I wanted to open up Feko on my home computer, I could. It's just one of the great things about Altair One. So, if you have further questions about that, that's definitely something we can chat about. Kind of the last thing I'll bring up is we have a blog and a lot of sort of resources. I encourage you guys to check out our blog. That's something that I'm continuously updating, and some of the Altair engineers are continuously updating for just more technical information on how to sort of run things or set things up in Feko or HyperWorks, etc. Our social platforms, LinkedIn and Twitter, We're going to be doing more of these webinars and, kind of more videos, et cetera. Just encourage you to reach out. And lastly, our YouTube channel, if you just go to YouTube and type in TrueInsight, we're also pushing videos on that platform as well. So with that being said, I just want to thank you all for attending. I'm going to, turn it over to you guys for questions. I don't know if Kyle, if you have anything further you want to add.
Yeah, so appreciate that, Drew. Very well done. I just say for those of you on the call who want to look in more to this, please ping us. You can reach out to Drew directly even. We can absolutely set up some proof of concept studies if you have a specific application, you want to see how it's going to work, and if this is a tool you might want to look into utilizing. Additionally, coming into the year or the end of the year, we do have some pretty sweet promos going on right now for those that might want to be looking to move over for Feko or any other tools for that matter in the Altair suite. And then the other thing that I'll say is we are seeing a lot of customers coming to us saying, hey, we're getting word from our accounting department that with some proposed tax changes coming next year, we have some allocated budget. We want to take advantage of some tax savings this year, depending on the application and how they're buying it. But please, if there is a tool out there that you do see some additional interest in, let us know. And then, I would encourage you to ping your finance folks, because we are seeing more and more demand coming out of accounting, ironically enough, versus engineering based on some changes that are proposed for next year.
Great, thanks, Kyle. Is there any other questions? I think I see a question in the chat from you, Praveen. I don't know if there's specific frequencies, if there's a specific frequency bandwidth you're looking for. I don't know off the top of my head, but if you can jot your email down, I can sort of send you the frequency bandwidth in terms of how high and how low. Like I sort of mentioned, with low frequency applications, you're going to be probably jumping into flux versus high frequency applications. But if there's a specific range you're looking for, let me know, and I can sort of check the user manual for that specific, but frequency bandwidth you're looking for. Is there any other questions? Oh, I appreciate that, Aloke. If you do have any questions, feel free to reach out. I'm going to throw my just my contact information in the chat. If anyone does have any questions about anything at all, feel free to reach out. And I look forward to chatting with you all. I'm going to stick around in the chat for a few more minutes, but if you have no further questions, thank you all again for attending, and hopefully we can chat again in the future.